Okay, so here, this seems kind of random, this first preview exercise. A median starting salary for a person with a bachelor's degree in the humanities and sciences or social sciences is $34,000, as opposed to the median starting salary of a person with a bachelor's degree in engineering, $68,000. How many times as much money does the engineer make than the social scientist? Twice. 2 times, right? 2 times as much. How did you come up with that number? Divided. Yeah, we took 68,000 divided by 34,000, and it's 2 times as much, right? Because 34,000 times 2 gives you the 68,000. All right, we're gonna, that's just a wording thing that I wanted us to be used to for later in today's class. All right, can you give me an example of a number that might be used to report the magnitude of an earthquake? 2.4, 6, 6.0, 7.0. There actually is no highest. Yeah, it can go up and up and up. But the whole idea is that it goes up and up and up, but it goes up logarithmically, right? And if you look at a log function, it goes up very slowly. So an earthquake can get a lot more intense, but the number on the Richter scale doesn't go up very much. Well, similar processes are involved with the Earth, right? Yeah. Okay, so log functions are often used to scale very large or very small numbers into numbers that are easier for our brains to digest. Okay. So we're going to look at 3 common models for log functions. The Richter scale we'll do together, and then you're going to look at pH and the decibel scale in the class activities. All right, so earthquake magnitude. Seismologists generally determine the Richter scale magnitude of an earthquake by looking at a seismogram, right? And this is a typical one. The Richter scale defines the magnitude of an earthquake, M, to be the log of I over S, where I is the intensity of the earthquake as measured by the seismogram, and S is the intensity of what we call a standard earthquake. It's the smallest detectable movement by a seismogram. Okay. So S is just some number. I don't know what it is, and it doesn't matter, but it's a constant. It's a number. Okay, so the 1906 earthquake in San Francisco had a magnitude of 8.3 on the Richter scale. S is what? Standard. No, because this is earthquakes, not sound. Yep. S stands for standard. Standard earthquake. I stands for intensity. M stands for magnitude. Okay, so at the same time in Japan, there was an earthquake that had a magnitude of 4.9 and had only minor damage. The 1906 earthquake in San Francisco was a really bad one. It's well known. So the question is, how many times more intense? So this is where we were talking about the how many times more does the engineer make than the social scientist. How many times more intense was the San Francisco earthquake than the Japan earthquake? All right, so let's analyze both of them. For both of them, I know the magnitude, right? They gave me the magnitude. That's the Richter scale number. But they're asking me about intensity, right? We're being asked to compare the intensities of the 2 earthquakes, which is I, right? So we know M, and what we want to know is I, so that we can compare them. So let's look at San Francisco. I'm going to write down the formula. Magnitude is the log of the intensity over a standard intensity. And S is just some number. It's the smallest intensity detectable. Okay, so for San Francisco, the magnitude was 8.3. So I replaced the M with an 8.3. Okay, I would like to solve this equation for I. Anybody remember from the day we learned how to solve log equations? What do I do? I want to get rid of the log, right? As opposed to moving it around. How could I get rid of it? Yep, there's a little. Yep. You got it. Good memory. So when you have a log equation, the key to solving it is to get rid of the log by changing it to an equivalent exponential equation. So the base on the log is the same as the base in the exponential, and then the 8.3 and the I over S kind of trade places. And then if I want to get I by itself here, what's the last thing I have to do? Multiply by S. Okay, so I in San Francisco is S times 10 to the 8.3. I changed my S's to cursive because sometimes I get confused with fives. Okay, so S times 10 to the 8.3. That's San Francisco. All right, now let's look at the Japan earthquake. Start with the same formula. Magnitude is the log of I over S. Magnitude here is 4.9 equals the log of I over S. There's a little hidden 10 there that they didn't give you in the formula, but if there's no base shown, you assume it's 10. And then how do I change this to an exponential equation? 10 to the 4.9 equals I over S. Yeah, and then just multiply both sides by S. I is S times 10 to the 4.9. Okay, so now I have the two intensities. I've got the intensity of the San Francisco earthquake, the intensity of the Japan earthquake. I want to know how many times more intense one was than the other. How did we calculate it when we were doing the salaries? Division. Yeah. So my answer is that I'm going to divide S times 10 to the 8.3 divided by S times 10 to the 4.9. This will tell me how many times bigger the San Francisco intensity is than the Japan intensity. So my S's cancel. So that's why it turns out I didn't need to know what it was. It's some number, but it doesn't matter. And then what's 10 to the 8.3 over 10 to the 4.9? You subtract, yeah. 10 to the 3.4? Yeah, I think that's right. 10 to the 3.4. Let's put that in a calculator. Ten to the 3.4 is 2,512 if we round to the nearest whole number, times as intense. Yeah. Yeah. So yeah, so the Richter scale numbers go up pretty slowly, but when you jump from one Richter scale number to another, like from a 7 to an 8 or a 6 to a 7, increasing the magnitude by 1 actually corresponds to increasing the earthquake intensity by a factor of 10, right? So the difference between a 6.0 and a 7.0 is actually 10 times as intense. Right? So 2,500 times as intense is a really big difference, right? Wait, but you're going from like 5 to 8. It's 10 to the 3.4. Yeah. So it's 3.4. The difference between the two is 3.4, right?
No, I know, but you said going from a 6 to a 7 magnitude
would be 10 times as intense.
So if we're going from a 4.9, which is almost 5, to an 8, it would be like only
10 to the 3. It increases by 10, a factor of 10 3 times, which would be 10 to the third, times 10 times 10 times 10, each time you go up by 1. Yeah. So there are lots of things that we measure this way, because if we had to say If we had to give intensities, right, instead of magnitudes, they would be really big. They'd be really, really big numbers. So instead we take the log and it makes them smaller numbers, but it has this effect of making the difference between a 4.9 and an 8.3 appear smaller than it is, right? So there are lots of things that we do this with. One of them is pH. Another one is decibels with sound. And another one is the brightness of lights. So I'm going to have you work with some of those. You're going to do similar things to what we did with the earthquake, and I will help as needed.